So now we're starting with a very important topic. We're going to talk about variance and standard deviation of a population. So imagine you have a data set like this. All the numbers are pretty close together. When we find the mean by adding up all the values and dividing by how many we have, we find the mean to be 12.6. Now imagine you have a data set like this. The numbers are kind of spread out. It starts off low, 1, 1, 2, and then goes all the way up to 31, 36, 42. Now when we add those all together and divide by how many we have, we also get 12.6. So you have two data sets here with the same mean, even though the data sets look very different. How are they different? Basically, how could we describe that difference? Well, dispersion refers to how spread out the data set is about the mean. Variance and standard deviation are the two main measures of dispersion within a data set. Now I have two equations here, the equation for population variance and population standard deviation. These are commonly called the definitional formulas, and they take a little bit longer to do. Eventually I'm going to teach you the computational formula, which is a lot shorter, but it does make a little bit less sense. Now notice in these formulas we're using capital N because we're talking about population size, we're using mu because we're talking about population variance, and we're using sigma because we're talking about population standard deviation. If we were doing it for sample, we'd be using different letters. That's one of the ways to tell the difference if you have to. So I'm going to organize everything into this table, and I'm going to do this step by step to show you how to come up with population variance. Note that I've put my x's into the x column, and we're going to need to find these additional columns to calculate the final answer. So we can find the mean of this data set to be 2.83. We just add together the 6 values and divide by 6. So I'm going to put mean into that column there. Now the next thing we need to do is subtract each individual score from the mean. That's called a deviation. We're going to find out how much each score deviates from the mean, which I've done there. Negative 1.83, negative 0.83, and so on. But if we were to add all those values together, we'd get 0. So in order to actually do math with this, what we're going to have to do is square it like that. So now we have 3.35, 0.69, 0.69, and so on. So the top part of the equation, you can see things in red, that now we have to add everything together. That's what that sigma means next to the x minus mu squared. We have to add together all of those squared deviations. And when I add together those squared deviations, we get 10.84. Now the last step is to divide by n, how many squares we had. So when we divide 10.84 by 6, we get a variance of 1.81. So back to these equations, we found the variance to be 1.81. Now the standard deviation is actually pretty easy to find, because in order to find it, you just take the square root of the variance. So if our variance is 1.81, that means our standard deviation is 1.35. That's the population variance and the population standard deviation. Now we just calculated variance and standard deviation using the definitional formulas, which takes a long time. To speed things up, we usually use the computational formulas. They'll get us the same answer, and we won't have to work as hard. So these are the two formulas for the population variance and population standard deviation. So I'm just going to put that up here. So now I'm just going to replace the n's with 6's, because we know that we have 6 numbers. Now we're going to need to find the sum of all x squared and the sum of all x squared. I'm putting these two things next to each other because people often get them confused, and I want you to see the difference. In the first one, you square the x's first and then add them together, and in the second one, you add them together and then square them. So we get sum of all x squared of 59 and the sum of all x squared of 289. So I'm just going to put those things into the equation, and now we're pretty much done. We can easily solve for variance, which I've done right here. And just like before, we come up with the same answer. We get a variance of 1.81, except in this case, it was a lot easier. It didn't take us as long as before. And again, we just take the square root of the variance to find the standard deviation, which is, again, 1.35. Hopefully that wasn't too complicated. So from this video, you understand how to calculate the population variance and standard deviation. Also understand that this is a measure of dispersion. Like before, mean, median, and mode are measures of central tendency. Now I'm talking about measures of dispersion. And also notice that there are two different formulas for calculating standard deviation. There's the definitional approach and the computational approach. The definitional approach is a little bit longer, but it makes more sense, whereas the computational formula is easier and makes a little bit less sense.